Hey everybody, back to another day. Today is the 2nd of January. Um, we're just going to be doing basically the same thing we did the day before. We're going to warm up with a typing test. That way I don't hurt my fingers as much. And then we'll go to Leetcode, the daily problem. Alright, let's kick it into gear. Do a warm up. Now, once again, I'm not really going to care about this. I'm not even logged in, so it doesn't really matter. 108 isn't bad. Okay, so we're going to go ahead and go to the daily problem. It looks like number of ways to split an array. Oh man, hold on. Let me refresh this for you. Okay. I didn't look at it. Solution. You're given a zero indexed integer array nums of length n. Nums contains a valid split at index I if the following are true. The sum of the first I plus 1 elements is greater than or equal to the sum of the last n minus I minus 1 elements. There is at least one element to the right of I that is between 0 and n minus 1. Return the number of valid splits in nums. And we want to return the number of valid splits. Let's see. So we just need a total sum. And then we need to subtract the running sum. And if that running sum is greater than the difference, it is a valid split. So if we had 10, 4, -8, 7, and the sums coming up to this is 10, 14, 6, 13. Is it from the sum of the first? Okay, so it is from the beginning. And I guess we're looking from every beginning. So it's one split per. And there's always going to be at least one element for the right of I. Okay, so if we were to add all of these together as the sum, that's 24, 30, 43. If we go through, if we get rid of 10, so if it was 10 split here, then we would have 10 on this side versus 33. And in the case of the split, we're looking for elements on the left side to be greater than or equal to the sum of the right side. So if we just keep going, 10, 14, 6, 13, 24 to 19. So this is one greater split. But Oh, wait, no, because this is -1 at that point, right? Oh, I did this wrong. Okay, let's start over. Because I basically just summed up this way. It's more like this. So you have 10, 4, -8, 7. And this split is going to equal... right? So this is greater than the 3. So then we can keep on moving. This is 14, -1. There's always going to be 1, so the last one we can check, right? So this is what? 6 to 7? So we want a running sum of whatever's on this side versus on this side. So if we go this way, then the sum is reduced and increased. The first I plus 1 elements. Oh, I see. Okay, so, yeah. So there has to be 1 on the left side and 1 on the right side. What's the constraints? I bet I could just brute force this, honestly. We could just do a linear search. If I took int sum, or have it start at 0. Well, this isn't sum. This is going to be right. Right. Left. Okay, so first thing we would want to do is we want to add the nums I. So left plus equals nums I. We want to subtract that from right. I. And then we need a result. Ooh. Okay. And then if, was it left is greater than equal to right, result plus plus. Something like that. Now this is the, we got an O of n to accumulate, and then O of n for the for loop. And because we're not doing either sides, I'm pretty sure this will work. It's gonna be slow though. Signed integer overflow. Well, that's my fault. I did not check the constraints for the available values. Okay, well, that's a simple thing. It can go from -10 to the 5, 10 to the 5. A int would not be able to fit that, so we'll just switch this to a long. Oops. accept the result. Let's see. We're adding this, so we want to convert this long longs as well. Right. Okay. So that should handle the constraints. No, it doesn't. Whoa, wait, hold on. Oh, negative 2147. That doesn't handle it. Okay, what am I missing? I don't think I can convert. Is it the result? Well, they're all equal. Cannot be represented by an int. It's not represented by an int. Oh, okay. So here's where I messed up. Accumulate takes in the type right here. So this is thinking it's an int, even though I've told it to be in a long. So we have to tell it that it's a long, which I think I can just do it like this. We'll use this as test case. Yeah. So whenever you use accumulate, make sure that the type that you're using for the third parameter fits the type that you want to use. Yeah, there we go. Oh, I guess it wasn't as slow as I thought. I'm sure there's a faster way to do this, but yeah. Okay. Now that we've solved it, let's look at what submission I had kind of just skipped from before. 169. Why does this seem so much slower? Oh, geez, it was the exact same thing. Wait, I typecasted like this instead of using LL. I don't think that really matters. Oh. I definitely did think about this a little differently, though. I mean, it is the same thing, because left was the running sum and right is the total sum I'm subtracting off. Okay, well, this shows you the craziness that is the Leetcode test of speed. Okay, well, that's all I had for the day. I hope you guys have a wonderful day. Thank you very much.